All right.
There it is. Okay.
So here we are at the end of the Lean Six Sigma Greenbelt class, and we're going to cover a capstone. As previously mentioned, because we teach the classes in different segments, we don't want to leave everybody with the sense that it's these separate components. We want it to seem seamless, because it is seamless when done in real life. So what we're going to do is go through project analysis, project setup, the phases of DMAIC to see what it looks like when it's all put together. So we'll start off here. The first thing we're going to do is we're going to talk about how to select a project. Your project is going to be selected off of a few criteria, which are globally understood as good criteria to base a project on. Broad appeal, simple but not trivial, quick benefits, within a group's control, it's time bound, and the project can come to an end. All projects must come to an end. So just keep this in mind when you go through a project. You have different selection criteria. These are some of them. So you have your project selection criteria. You know what a project is. You know how to base your project. But what are you going to do in your project? So here we have a couple tools that are going to help us along the way in our project. And I'll orient you to the very leftmost column where it says select problem to work on. That's the very first thing you need to focus on when selecting a project is what the heck are you going to fix? What are you going to do to make things better? And there are a couple tools that help us, brainstorming. So we think with a group or we think with others, what the heck are we going to do? How are we going to benefit ourselves? The next thing you do is either a checklist. You review a checklist to see if there's anything in the checklist that needs to be updated. Maybe a consensus-based decision-making process is good for you guys. And then we'll kind of go through everything else. So we have to understand what the heck we're going to do first. So we have to have a problem. We have to identify a problem. And once we have identified that problem, we're going to write a charter, which is in essence a contract between ourselves and whomever is paying for our services, so that we understand what is success look like. When are we done? When am I done? And as a good project manager, you should always be trying to work yourself out of a job. And how you work yourself out of a job is you complete projects. And that's a good thing. So knowing when you're done is very, very important. We're not paid to manage. We're paid to close projects. We're made to get results. Don't manage things forever. So a project charter is going to do a couple things. It's going to orient ourselves to the business case. It's going to give us some goals. It's going to give us milestones so that we know where we are at specific times in the project, so we can base whether or not we're still continuing to be successful or we're trending towards success. Previously mentioned, and most important, the problem statement, what we're going to fix, how we're going to fix it, what are we going to do to implement some fixes. Very generic. It's not a solution, but is more of a definition of boundaries, where you will go, where you will not go as far as the project goes. What is the extent to which you will try and fix the problem? And then your team, you're going to want to find out who's on your team, what are they doing, how are they going to help you? And that's something you'll also want to mention in your charter, especially if you work in what's called a matrix environment, which we didn't cover in the class. But in essence, a matrix environment is where you are not in control of others. They have their own line managers, but they at some degree have been partitioned onto your project to help you. And making sure that you have a solid understanding between yourself and those line managers for how often and to what degree you can use the resources is always important. Not that they drag them off onto something else and then you suffer or your project suffers, which always happens. You're going to want team objectives. So in any successful team, you're going to need a couple things across the board. You're going to need a support system. You're going to want to make sure that people feel as though they're supported, they're not being attacked, that most importantly, they don't have to continuously try and defend themselves or make sure that blame isn't cast on them, but they feel open and stable enough as a group that they can come with some honest answers. Open communication is a big part of that as well. And organizational goals, making sure everyone's on the same page with their organizational goals. Creating a problem-solving atmosphere. So not who do we blame and how am I not going to get blamed, but okay, how do we fix this? Sometimes you might want to send an email, and instead of saying, well, Jerry or Todd did X, Y, and Z, maybe you send an email that says, I'm focused on the people behind this. I'm focused on the process behind this. What broke in the process to fix this? Or what broke in the process that made this go wrong, and how do we fix it? And then you're going to want to acknowledge individual achievements. So Adam or Leanne or Eric, when you guys do an outstanding job, y'all should be recognized for it. And it's important to set up a culture that does that. And the commitment, making sure everyone sticks it out. You don't want people to quit halfway through. That's really, really bad. So you have your team. Just understand that all teams will go through a team evolution. And we spoke about this in an earlier class. We're going to form, we're going to storm. So we're going to form together. We're going to storm a little bit. We're going to test each other's boundaries, see where we fit in on the team, see who's in charge of what by fighting a little bit, and it's natural. Norming. You're going to notice one day people just stop bickering with each other. And that is usually a good indication that you've entered the norming phase. And then eventually you're going to see people starting to collaborate with one another. That means you're most likely entering the performing phase. And it's a good idea as a project manager or as a Six Sigma green belt to acknowledge when different team members enter these different phases. It's not that all of your team as a group will enter norming at the same time, but you might notice two people, like all of a sudden Jerry and Paul, they're not fighting anymore. You don't get a bunch of bickery emails. You don't get a lot of complaining phone calls. Maybe they're starting to norm. And it's important to not acknowledge that, not so much so that you can track your progress towards performing, but that you can acknowledge whether or not you go from performing back to norming. Maybe something went wrong, or maybe from performing to storming, something goes wrong even more so. And it's important to acknowledge those milestones so that you can make sure that your team is focused on performance. And then adjourning. At some point, you're going to need to leave. The project will be over, and it's important to have a plan in place so that people don't get laid off, so that people know there's a future awaiting them somewhere else in the organization, or that they're going to be recognized in some form or fashion at the end of the project. So keep that in mind. When you bring people on, you're going to need to do something with them at the end of your project. Okay, when you got your teammates, you're going to have people who are internal stakeholders. Those might be people on the company staff. They might be people on your project team. And what you're going to do, whether they're internal or external stakeholders, you're going to perform a little bit of analysis on them to make sure that they have the information they need to support you in the ways you need to be supported to be successful. That's really what it's all about. Whether they love your project or they hate it, they need to have the information so that they can support you and you can be successful. So if you're building a bridge over an Indian burial ground, it's important that the right people have the right information to make sure that you are successful. And whether or not that's informal or formal, public, private, make sure everyone has the right information so that everyone feels enabled, successful, and y'all can collaborate on a win. Balanced scorecard. So this slide is a reminder for us all to measure the things we are being held accountable to. So Leanne, we had that conversation earlier where you want to measure the things that you are being accountable to as success measures. So if your success measure is 100% of your students are successful within your time frame, you're going to want to measure that. And if you have to measure that over time to like a leader or your sponsor, you're going to want a scorecard or maybe just a PowerPoint or an email that in some way quantifies that you are still successful, or if you're not meeting your criteria, that you're going to at some point in time that you can predict going to be successful. So we had an 80% success rate now. At the rate we're going in 4 weeks, we'll be 100% successful. That's just as good of an answer at some point as 100% successful today. As long as you know where you are and you know when you're going to get to the point where you need to get to, that usually is just fine. And then once you have all that in place, the last thing you're going to need is a project plan. And there are 3 things that you need to make sure that you have covered in your project plan. And that's scheduling, that's controlling, that's planning for the future. So there are time considerations, cost considerations, and scope considerations, and I've baked those into these 3 things. You want to make sure that your project plan, when you exit the gate, is pretty darn rock solid. Not 100%, because you will never get to 100%, like we talked about earlier, until you're done with the project. But you need to be 30% of the way through it before you set foot out of the gate. You need to know what you're doing, where you're going to go, and how you're going to get there. And then along the way, control that plan as best you can. So that covers the project management part of the course. And I wanted to recap where we are right now. We have a team, we have a charter, we have a project, and we have some ideas for what we're going to improve. So we now have a process that we're going to want to improve. What is this process? Well, we're going to want to find out. That's the D in DMAIC. So here we are defining what our process is. Here we have a customer need. We need to be at work at 8:30. So maybe the problem statement is we're not getting to work at 8:30. And we have our process at a high level laid out in our process map. We have an idea in our mind of what we need to do in order to get to work at 8:30. So we're going to define that a little bit more through value stream analysis and a process map, which is one of the tools that you might want to consider as part of your green belt project. So we have the actual process in depth in a Visio diagram like Leanne you showed, or some other tool to break out what is in our process, and then you want to identify where the non-value added components are within your process. So what are you doing to get up in the morning and out and ready and off to work that aren't providing value? Is it valuable to eat a second bowl of cereal? Maybe, maybe not. You don't know that until you do the analysis, but it's important to identify the different touch points or handoff points or bottlenecks within your process and identify those as potential waste. So with the success criteria in mind, you can also use a Pareto diagram. So we use the analogy that 80% of the issues, 20% of the issues cause 80% of the problems. And here is an example of that. So a different example, this is restaurant complaints. But you can see the type of complaint equals 80% of all complaints received. And that's about 20% of the total number of complaints. And this would normally ring true for any process, but something to consider when trying to identify which issue to fix. Because most of the time you're only going to want to fix one issue at a time so that you can keep your process in control and have a more scientific method in place as you fix things. You don't want to fix more than one thing and introduce too many variables and then lose control of what you're trying to do. And then we also have a fishbone diagram, which we love to talk about. And Adam, you did a spectacular job showing us your fishbone diagram today. And yes, he did. Fishbone diagrams have a couple different things that they look at, and it's a possible view into the causes of defects. And it's a way to brainstorm in a very methodical way what could be breaking in your process. So another tool you might want to use when considering which problem in your process to fix, like materials. Maybe your shower is broken, so you have to go downstairs to use the guest shower, and that's eating up time. Or people, maybe your significant other snores and you sleep past your alarm because they snore or something like that. So different ways to brainstorm.
One thing with Leanne, with your project, you can actually use a fishbone diagram to list out.
I know I want to.
If your problem is the not being 100% complete, you can put in the people not being, and then the secondary cause would be they're not trained or they don't know how to use the material. The materials could be the glitter gets everywhere, the glue doesn't stick right, the magnet didn't have a sticky thing on the backside. The method, how you put it together, the different machines or tools that you need. You can list all that out to create a Ichikawa diagram or fishbone diagram.
I'm going to. It'll be very fishy tomorrow.
Okay.
Awesome. Okay, so once we have an idea of what we are going to fix, let me just fix something real quick. How's that? Is that a little bit better?
Mm-hmm.
Okay. So once we have an idea of the things we're going to fix, we need to choose the correct type of project or process to help us along the way. So is it a PDCA or Plan, Do, Check, Act? Is it its very close cousin, Plan, Do, Study, Act, or PDSA? Are we going to go with a classic approach or a DMAIC approach? And then not listed here, if it's a new process, are we going to do Design for Six Sigma or something like that? These are things to keep in mind before you get started so that you have the right tools in place and you start communicating these things at the right time to the right stakeholders. You definitely don't want to say, oh, I'm going to do a DMAIC project, and then you tell your sponsors and the people paying for you, oh, we're doing a DMAIC project, and then 6 months later figure out, yeah, PDCA is probably a better choice. and then you have to re-communicate that to everyone who just spent 6 months paying for everything. Yeah, we're actually doing something completely different. It shows a level of non-control that you don't want to show. But with that in mind, we have Plan, Do, Check, Act, Plan, Do, Study, Act, which are iterative approaches. They're cyclical, so they go in a circle, and you'll do a quick win. I look at something, I decide on a fix, I implement my fix, I review how that worked, and I make plans for another fix. So we also call that a Kaizen, or a process in which we're continually seeking to be perfect, or have a process with zero defects and waste. So we know at this point what our project is, who's on our team, what we're doing, and the methodology that we're going to select. Perfect. Now that we know our problem, now that we know how we're going to fix it, it's time to start collecting data. Now we're in the measure phase. So I have here just a very simple check sheet. And Leanne, you did a phenomenal job with your check sheet. And you said over the number of iterations per student, these are the things that I found that were defective. And here we see Monday, Tuesday, Wednesday, Thursday, Friday, and then a total. And then we see with little tally marks, and maybe they were checking them off as the process happened, what type of defect they saw through their process. And on the bottom, they see defects by day, so total defects by day. And then at the end, we have total defects by type at the end. And this is great, but we need to visualize it, right? Because it's very difficult to look at something like this with tally marks and be able to say, oh, well, our sigma value is X, and if we do Y, then we can get a sigma value of Z. It's really very difficult to do that. So we're going to want to graph this in a way. We're going to want to process this information in such a way that it becomes valuable to us.
Yeah, this is the way that I did my, kept track of the errors that I found when I was doing limited scope. As I just had a check sheet, and every time I find a certain kind of error or discrepancy, I just put a tick mark, and then I plugged it all into an Excel spreadsheet.
That's perfect. That's exactly right. And then when, like we were mentioning earlier in the class, doing a scatter chart and just seeing what happens to the data when you put it on a scatter chart, that's important. So here you can see the data doesn't seem to follow any kind of pattern, but they were still able over time to give us this red line, which is probably the mean value or the average of all of these values together. So they were probably measuring the same thing, a value of that same thing, maybe stickiness of glue, or how well a stamp shows up on a M&M or something like that over time. And so they were able to measure that on a scatter diagram. Sometimes you'll notice patterns. So here we see a pattern that's trending upward, and there's a lot of correlation associated with the data. So we can definitely say with a strong level of confidence that over time, this happens. And we can graph that with an equation, y equals mx plus b. And sometimes it doesn't.
I had that on my chart, and my trend looked just like that positive trend. I had a line that just continued up towards the 62. So it followed the control group.
Awesome. And sometimes you might notice that it's not going to correlate exactly, right? So this one kind of dips down a little bit, but they were still able to get a line out of it. And we went through some of the tools that help us find the best line or the best shape to meet all of or most of our data points. Mm-hmm. And then we also covered a process shift. So we see things are moving along that are within the boundaries for control, and then something happens. Adam gets a vacation and he's off, and all of a sudden productivity changes. And then we're doing something else. So
what about the messy one?
The messy one? The messy one.
Yeah, that one to me
help us remember to analyze outliers. So we have some graphs out here, and it's important to understand what our outliers are. So this up here might be an outlier, and it's something that's just worth investigating. So if you see something that's way out in the ether, you get some kid that finished his activity in 5 minutes and everyone else took 15 minutes, it might be worth noting, what did that kid do? Right. What was so different about his process that he was able to achieve such different results? And whether or not that's a good thing or a bad thing. And it will either help you identify better corrective actions or help him to then refocus his efforts to be more like everyone else so that he can be more in line with everyone else, if that's your goal. So if your success criteria is the shortest time frame to get everyone through the pipe, you might want to change everyone to be like this one person. Or if it's the opposite and you want everyone to finish at a specific time, maybe you need to adjust this outlier to be like everyone else. So it's just worth noting. That's all it is. Just graph your data so that it makes an interesting point so that you can see it, because you wouldn't be able to detect an outlier so much from here. You might be able to say, oh, that's 7. Oh, that's also 7. But if you look at it here, you go, oh, wow, yeah, that's different. That's big time different. And then compound events. So it's important to understand we single out one defect at a time, and we single out one relationship between the process and that defect at a time, so that we don't have to deal with so many if-thans. If I do this, then this, and this, and this. What you really want to focus on is whether or not if something happens, something also happens. And in this case, they will be mutually exclusive. So if this happens, so if I'm brown and I'm a cow, I could be a brown cow.
Yeah.
Or if I'm brown, but I'm something else, then I'm not necessarily a cow.
Right.
And this diagram shows a little bit something a little bit different than that, but you get the point. So you could be one thing and something else, or just the two things combined, but you need to understand what exactly are you looking at. And are the things you're looking at a result of 2 or more factors? Here's a better example. So we have no clouds and rain with no clouds and clouds. So what exactly are we looking at? Are we looking at days with no clouds, which is this big population? Or are we looking at days with clouds? And of the days with clouds, sometimes it's rainy. But what exactly are we looking at? And what's the relationship to everything else? And is it mutually exclusive? Can you have rain with no clouds? Well,
Yeah. No.
it was so humid the other day, I didn't see any clouds, but it was kind of rainy.
Yeah. That's heavy air.
That's Georgia.
Yes.
I threw this in here just so that you guys could get an idea of normal distribution one more time. So we have our population, like Leanne, you have the number of students to complete an activity in 15 minutes. And 15 minutes is the success criteria. So how many of your students completed in 15 minutes? And then here you can have the number of students, and you can have your normal distribution going out and back to show over time. And you can see over time how many students finished in a quick amount of time, a normal amount of time, and then a long amount of time. And so you can kind of do maybe a normal distribution to show the normal distribution of students who complete an activity over a certain given amount of time. Or Adam, for yours, you can do the number of deployers who deploy and the number of deployers who successfully deploy with all their kit in a given amount of time. Same thing. And then if we plot that over time, we're going to get, Leanne, remember the X bar? So the mean of our sample average. So our X bar here is going to be right there.
Mm-hmm.
So our X bar will be right there, and we'll plot that right here. So the mean value of our population, and then if we do population 1, 2, 3, 4, etc., all the way to the end, then we'll get this control chart showing of our total population what's in range and what's out of range. And if you remember our class from last week, we have our upper control limit and our lower control limit, and there are 3 sigma difference. So that's 3 sigma on the top, 3 sigma on the bottom.
Standard deviation. 3
standard deviations. And it's important to note that although it's out of control, and some of these other ones are still in control, but they're different than the mean, it's important to identify trends within this so that you have an understanding of how much of your population has just shifted. So for example, we use the president, and if the president's approval rating shifts 2 standard deviations, it's still within control, but that's a heck of a lot of people that maybe like or don't like the president anymore. It's worth noting. Here's another visual representation of that. So we have all this data. What do we have now? So we have our project, we have our team, we have our defects that we're measuring. We've measured our defects. We've looked at our process. Now what? We need to analyze root causes. So out of all this information and all the visualizations we've done, what the heck is actually going on? And we need to draw some conclusions. We need to find the root cause of our problem. This is the analyze phase. So when we draw conclusions, it's important to note our correlation coefficient. So of what I'm saying, how much of it correlates to the data I'm seeing? Is there a strong correlation or is there a weak correlation? And to what degree is what I'm suggesting equal the results that I'm seeing? And it's important to note so that you don't make a judgment or a change based off of your own opinion, but based off of mathematical data. So I saw X, I was able to determine that X has a strong correlation coefficient to the root cause. So if I change X, I will change my root cause and I will positively affect my process. And we do that with also confidence intervals. So at what point are we confident that our data represents the whole process? So just one more thing to keep in mind. And then Adam, you did a phenomenal job with your FMEA. So I had to throw in an FMEA. And at this point, we are in Analyze and we're doing FMEA, or Failure Mode Effects Analysis. And we're deciding of the failures that we see, which one is the most important, which one has the strongest likelihood of affecting our process in the best way possible. So in this case, we've taken the time to measure several different defects. And by measuring those several different defects, we can determine defect number 1 and defect number 3 have the most benefit, the most bang for the buck. So we're going to attack problems 1, and then we're going to attack problems 3, just because that's the level of effort it's going to take and the most bang for the buck. So we have our improvement steps here. We're going to generate and assess solutions, plan and implement improvements, and then prepare to control. And the people involved in developing these solutions. So remember to keep our teammates and our stakeholders in mind when changing the process. No, I'll tell you this, no one is more conservative than the people who, no one's more conservative about a process than the people who know it best and the people who invented that process. And getting them to change their minds is usually very hard.
Yes.
So including them in your project is a good idea because they will have buy-in to the solutions you come up with. And rather than springing an answer on them in 6 months from now, having them go through the change process with you and realizing the same results as you do will dramatically improve the likelihood they're willing to change the process for you. And you no longer have to spend another 4 months after you've done all this work to change their minds. Their minds have already been changed along with yours. Okay, now we're going to improve. So now we're in the improve phase. We're going to improve by generating some solution ideas. How the heck are we going to generate solution ideas? Well, we have a couple creativity techniques that we went over in class, right? We can think like a kid. So we can ask why a lot, right? Why this and why that? My kid asked me that one more time, I'm going to puke. We have creativity hats and creativity techniques. If you recall this, each hat represents a different type of thinking. And this works really well if you have a strong culture where everyone expresses themselves in a very similar way. If everyone's very bureaucratic or very authoritative, then this would help them think in different ways. So I will go down here just for a second and we'll cover the different hats real quick. So blue is managing blue. So what is the subject and what are we thinking about and what is the goal? So it's about managing. And white is about information only, so just the facts. And the red hat is for the emotional person. So the person wearing the red hat will just have emotions in mind, gut reactions. And black will be discernment. Okay, so identifying the reasons and being very cautious, very practical, very realistic. That's their role. And yellow will be logical, so they want to always think of things in a logical way that applies just the benefits and always sees things in situations. And then green is creativity. So how creative can you get? How outside of the box can you get? How nuts can your solution rather be? So that's a great way to come up with some solutions. So for this capstone, I just said, okay, so for a hypothetical process where I need to get to work at 8:30, we're going to do a 5S. So I apparently don't have my closet organized enough. Maybe that was my determination by looking at the process. Maybe I'm digging through the dirty clothes hamper, looking for some socks. Maybe the socks I have holes in them and I just can't tolerate that. So maybe I need to do a 5S project and I need to sort, set in order, shine, standardize, and sustain. And by doing that, I can save maybe in the hypothetical 15 minutes off the process, and that'll get me to work at 8:30. So I'm going to do a 5S project. So I'll do a quick design of experiments. So by doing a 5S in X way, I will result in Y benefit that will improve my success criteria. And setting that up in such a way that I fix one problem at a time with a standard process, which I've thought out. And it starts with a hypothesis, so your null, and your design of your experiment to test whether or not your new process is going to work. You actually test it, and then you provide some insight out of it. Okay. Now we're going to gather more metrics. We're going to make sure that what we did is effective. And then we're going to control our new process if it works. And we're going to make sure that as we go through our new process in the future, we always stay in control. So in a 5S project, that would be making sure that our 5S is still in conformance every week or every 2 weeks. Maybe on Sunday night, I iron my shirts and I tidy up my closet. And that's good enough for the week. And that's good enough. Over time, I can see that will keep my process in control. And over time, I might see that by the time Friday comes around, my process is out of control or just about out of control, but it doesn't matter because Saturday's coming around, Sunday will hit, and I'll resort everything, and I'll be good to go. All right. And that takes us to the last thing that we covered last week, which is total productive maintenance and making sure that everything stays ship-shape with 0 breakdowns, 0 defects, and that we keep total productive maintenance in check by designing for it. We plan for it. This is something we have to achieve through a deliberate approach. Okay, so standardization, modularization, functional packing, interchangeability, applying these concepts to a process that is already in control will just make sure that that control stays in process for longer. So Adam, one of the last things that you have to do for your project is what things will you put in place to make sure that your process lives on after you PCS to the next duty station? And
Right.
Putting some of these things in place will help you. So fault isolation, malfunction, accessibility, interchangeability, adding these concepts into your tactical SOP or TaxOp, or if you have a memorandum for record or a memorandum for understanding posted or something like that, or maybe create a cat of nine tails out of some cat 5 cable, some RJ45 plugs, and just whip everyone every time they don't conform to the process. That might
I
be
like
a good
that
way to get
idea.
it in there. Yeah.
It's the administrative documentation of Air Force methods.
There you go. There you go, Adam. Write
Yeah.
that down.
Yep.
Making
They're
more
gonna call it the
acronyms, just
Adam.
what the military needs.
Another acronym.
Yeah.
Yes,
You should sell it back to the military and make more money.
There we
you
go.
should.
Hey,
They
so
call
that's
it the
5
Adam.
weeks of work summed up in 46 slides over 30 minutes.
That was cool.
Wow.
And just like that, we proved that we can get through 5 weeks of work.
Yes, we did. And we did it well.
Did I just cut? Can you guys still hear me?
Yep.
Yep.
There you go. So I think Eric's having some
Yep.
connectivity problems. But so we went in much more detail. And I have a question for you guys. So what do you want to cover tomorrow? Tomorrow's our last